Now we are going to discuss two methods. First, we will discuss the group index method for flexible pavement, and then we will discuss the Westergaard's method for rigid pavement. So let's start from the group index method, which is meant for flexible pavement. Design of flexible pavement by group index method. It is also known as US Highway Engineers Group Index method. Group index should not be a new term for you. Group index GI is claimed to be a measure of the thickness of subbase required in this method. The thickness of base and surface, on the other hand, is varied according to the volume of commercial traffic expected and the group index. So basically this method is based upon group index. The higher the group index of the subgrade, the lower its strength and the greater thickness of subbase is required, and so greater will be the total thickness of pavement. The group index is based on classification test of subgrade soil as explained below. So this is the formula of group index, and you can see that there are different variables A, B, C and D are involved. Here A means that portion of percentage of subgrade soil passing number 200C greater than 35 and not exceeding 75 expressed as a positive whole number 0 to 40. So if the percentage passing through sieve number 200 is F, so it means the formula for A is F minus 35. And the range of this A is from 0 to 40. If the value of A is coming negative, it will be taken as 0, and if A values exceeding 40, so it will be taken as 40. Now look at B. B is that portion of percentage of subgrade soil passing number 200 sieve greater than 15 and not exceeding 55 expressed as a positive whole number, again from 0 to 40. So the formula for B, that will be F minus 15, and here F means the percentage passing through sieve number 200. And if the B value is coming negative, so it will be taken as 0, and if its value is exceeding 40, so it will be taken as 40. And now look at C. C is that portion of the numerical value of liquid limit greater than 40 and not exceeding 60, expressed as a positive whole number 0 to 20. So the formula for C is liquid limit minus 40. And if C's value is coming negative, so it will be taken as 0, and if its value is exceeding 20, so it will be taken as 20. D. That portion of the numerical value of plasticity index greater than 10 and not exceeding 30, expressed as a positive whole number, again 0 to 20. So the formula for D is plasticity index minus 10. And if D is having a negative sign, it will be taken as 0, and if D is exceeding 20, it will be taken as 20. So if you just consider the minimum values for A, B, C and D, that is 0, and the maximum values for A and B, that is 40, and for C and D the maximum value is 20. So if you just substitute maximum values of A, B, C and D in the equation of the group index, you will be getting the group index value equal to 20. So it means the maximum possible group index value is 20, and obviously the minimum group index value is 0. The design curves are based on the following assumptions with regard to compaction and drainage. So these two assumptions are very important. Number one, compaction of the subgrade to be not less than 95% of the maximum dry density obtained by the modified Ashton test. Number two, the subgrade to be sufficiently above the water table to permit the proper compaction of subgrade prior to placing the base or subbase, and soil drainage or sufficient embankment height to be provided where necessary to keep the water table at least 3 to 4 feet below the road surface. So road surface means the top of wearing course or surfacing. Well, in this method, pavements can be designed in two ways. The case 1, pavement with subbase. That means we are going to provide the subbase. And the case 2, pavement without subbase. That means subbase is not being provided. So typically we are having these components of the flexible pavement. So you can design your pavement with subbase considering light traffic, medium traffic and heavy traffic. To carry out this trial, that is the case 2, pavement without subbase. So what we do, subbase will not be provided and some thickness of the base will be increased. Keeping this thing in the mind that base is superior to subbase. So I will repeat, when you are considering this case, that is the case 2, that is the pavement without subbase, so it means what we are doing, we are just going to increase the thickness of the base. So we are just going to substitute the subbase by additional thickness of base. So that is the basic concept which is involved in this case too. So here you can see light traffic case, base, and above that just surface. Here this is the medium traffic, so obviously base thickness is more, surface thickness also more, and here in the case of heavy traffic you can see further increase in the base thickness and further increase in the thickness of surface. Same thing can be seen over here. You are having minimum thickness of the pavement in the case of low traffic and the maximum thickness in the case of heavy traffic. So the design curves developed by US Highway Engineers Group Index design chart method. So look at this one. The vertical axis is meant for group index of subgrade. I will repeat, group index of subgrade. And along the horizontal axis we are having the thickness in inches. And you can see there are 4 curves A, B, C, D. Firm lines have been used in these curves, and dotted line has been used in the curve C. So in fact there are 5 curves. Now look at curve A. The description is given. This will be used to determine the thickness of subbase required. Curve B will be used to determine the total thickness of surface base and subbase in the case of light traffic. Curve C will be used to determine the total thickness of surface, base and subbase but corresponding to medium traffic. And curve D, that is meant for the total thickness of surface, base and subbase in the case of heavy traffic. And this is the curve E, that is to be used in the case 2. And you can use this curve to determine to get the thickness of additional base which may be substituted for subbase of curve A. Now look at the description which is given regarding the light traffic, medium traffic and heavy traffic. When you are having less than 50 commercial vehicles per day, that traffic can be considered as light traffic. When you are having 50 to 300 commercial vehicles per day, that will be considered as medium traffic, and heavy traffic means more than 300 commercial vehicles per day. And remember this thing that in the case of light traffic, thickness of surface is equal to 1 inch. Thickness of surface is equal to 2 inches in the case of medium traffic, and in the case of heavy traffic 3 inches will be taken for the thickness of surface. Look at the horizontal axis, this one, and here the group index value is 0. This axis will be used when your subgrade belongs to A1A group. A1A is the best material for the highway construction. If you have got some other material other than A1A and the group index is 0, then this axis will be considered. So I will repeat, this axis is meant for A1A, and for A1A is the group index is 0, always 0. For other materials other than A1A, if the group index is 0, then you will have to consider this axis. So by using these curves A, B, C, D, you can design your flexible pavements with subbase. And if you want to omit the subbase, so in that particular case, the curve E will be used to determine the thickness of additional base which may be substituted for subbase of curve A. Let's say the group index of the subgrade, that is 10, and you are considering the case 1 in which you are having all the components, that means subbase is there, base is there, and surface is also there. So what to do? Curve A, this will give you the thickness of this much, and you know this is the thickness of subbase. Then corresponding to 10 group index, you can proceed to curve B, and in this way you can get the thickness, the total thickness of the pavement in the case of light traffic. Corresponding to 10 group index, go up to the curve C, and in this way you can get the total thickness of the pavement in the case of medium traffic. And if you are considering the 10 value of the group index, now go up to the curve D, and in this way you are getting this much thickness, that is corresponding to heavy traffic. So in this way you could be able to consider the case 1. And if you want to use curve E, so corresponding to 10, you can see here this much thickness, that is the additional base thickness which is required to substitute the subbase of curve A. So in this way you can design your flexible pavement in the both cases. Case 1 when the subbase is present, and the case 2 when the subbase is not there. Okay, now we have reached here, that is the design of rigid pavement by Westergaard's method. So design of rigid pavement by Westergaard's method. This design of rigid pavement by this method is based on the following 3 parameters. Number 1, wheel load. W. This is the heaviest load transferred by a single axle vehicle with a dual wheel assembly. Number 2, allowable flexural stress of concrete, and it is being denoted by small f. So the allowable flexural stress in rigid concrete pavement is determined by testing a standard beam. The flexural stress modulus of rupture corresponds to failure in flexure. A factor of safety should be applied to the modulus of rupture. The factor of safety as recommended by Portland Cement Association ranges from 1.75 to 2. Number 3, modulus of subgrade reaction, and it is being denoted by small k. So modulus of subgrade reaction is determined by carrying out a plate load test on the subgrade material using a 30 inches diameter plate. Several different plates with decreasing diameter are used to provide stiffness to 30 inches diameter plate. So 30 inches diameter plate, that is the standard plate. The modulus of subgrade reactions K is defined as P over delta. So this is the simple formula for the modulus of subgrade reaction, where P is the pressure that is applied to the soil, usually 10 psi or 0.7 kilogram per square centimeter, and delta is the corresponding deflection, that is the pressure causing unit deflection of the subgrade. So this is the setup for the plate load test. On the next slide you can see this setup on an exaggerated scale. So look at that. We are having this assembly and the proving ring, the jack that have been connected to these steel plates. And look at that. This plate is having the diameter of 30 inches. Above that, the plate is having the diameter 24 inches, then 18 inches, 12 inches, and 6 inches. So in this way, we can provide the stability to this standard plate of 30 inches diameter. And the settlement dial gauges have been connected, one over here, and one is behind that. So at the equal distances, we have installed these settlement dial gauges. So this is the plate load test setup. So in fact, you will have to maintain the pressure of 10 psi through this assembly, and under the influence of 10 psi, you will have to determine the average settlement through these dial gauges. So if you have got the allowable stress of concrete in psi, you are having the V loads, the modulus of subgrade reaction value with you, that is P over delta, and the V loads. So when you are having all these three things with you, you can determine the thickness of the rigid pavement, that is the concrete slab, very easily. So look at this one. Let's say the allowable stress in the concrete is 450 psi, and the modulus of subgrade reaction is, let's say, 200. So 200 curve is this one. Look at that. So corresponding to 450 here, that is the allowable stress in concrete. Move up to here, that is this one, that says, the modulus of subgrade reaction is 200 pound per cubic inch. And then look at the V load. Now from this point you will have to move in the upward direction or in the downward direction accordingly by looking at the wheel load that we are considering. Let's say that is 10,000. So you can see 10,000. For that you will have to move in the downward direction in this way, and you can see that somewhere here this is the curve which is meant for 10,000. Then you can move horizontally in this way and you can get the thickness of the concrete slab. So very simple. So three things are needed: allowable stress of concrete, modulus of subgrade reaction. We have already discussed the modulus of subgrade reaction, that is P over delta, and the V load. So in this way we can determine the thickness of the rigid pavement very easily according to this method developed by Westergaard. Now some important points related to this method. In case of clay soil, the pressure is applied until the rate of increase of settlement becomes less than 0.002 inches per minute, because in the case of clay soil the settlement is totally time dependent, and in that case when you are dealing with the clay subgrade we use this criteria. Now this point is also very interesting. If plate size used in a plate load test is less than the standard plate size. What is the standard plate size? That is 30 inches diameter plate. So if plate size used in a plate load test is less than the standard plate size, the resulting modulus of subgrade reaction is increased. Why is it so? The reason is that when you are using a small size plate in place of 30 inches diameter plate, so when you are applying the 10 psi pressure, so it means you are going to apply a small force in that case because the contact area is less. So in that particular case you would see that the settlement, average settlement will be less. The formula for the modulus of subgrade reaction is P over delta. If delta is less, so obviously you will be having the increase in the value of modulus of subgrade reaction. So I will repeat, if plate size used in a plate load test is less than the standard plate size, the resulting modulus of subgrade reaction is increased in that particular case. The test is performed in the field corresponding to natural moisture content. Modulus of subgrade reaction is modified for the worst condition of the subgrade, that is full saturation of subgrade is to be considered. For this purpose, two undisturbed or block samples are collected from the site to perform unconfined or triaxial test. So one of the sample is subjected to 10 psi pressure under normal conditions, and the other sample is subjected to the same pressure after full saturation. So as we are maintaining 10 psi pressure, so it means the product of modulus of subgrade reaction and the settlement, that is equal to a constant. So considering this concept over here, we can write this equation that K sub modified into delta H saturated equal to K multiplied by delta H field. So K modified, or the modified value of the modulus of subgrade reaction, that is corresponding to the worst condition, that is equal to this. So here the modulus of subgrade reaction corresponding to normal condition, and this K sub modified, this is the modified value of the modulus of subgrade reaction corresponding to the worst condition. So delta sub H field and delta H saturated. Look at the description over here. Delta H saturated, that is settlement in saturated sample, that means the soaked condition, and delta H field, that is the settlement in sample with natural moisture content, that means corresponding to field condition. So in this way we can modify the modulus of subgrade reaction value accordingly. So in this way we have discussed the two methods. First, we discussed the group index method for the designing of flexible pavement, and then we discussed the Westergaard's method, which is meant for rigid pavement. Thank you.